This conference will now be recorded.
Oh, thank you for remembering that, whoever remembered. So I'd like to propose we talk a little bit about the scope first, and then jump into the stuff I put about the data coming in, the analysis we want to do, and the results we want to get.
Makes sense to talk at a high level first, and then get into more details.
Okay. So look, so and Shen, if I'm not saying your name right, please correct me. But would you mind kind of introducing what you wrote and walking us through it?
Sure. Yeah. Can you hear me? Yeah.
Yes, we can hear you.
Yeah. Just title putting some proposal. Definitely we can adding more and any changes.
Hmm.
And probably I'm Shinjo from Intel. We're working for the Intel memory failure analysis and prediction. And taking some scope, we're thinking there's a two type. One is a standardized on memory error telemetry. And there could be including formatting content for better fleet scale effective RAS management. And the output could help to do the troubleshooting or RFU replacement or RAS action. We know, as we discussed the last meeting, we know current practice when we in the fleet, typically we're using the counting-based CE data or UE data making the decision, but that will be a there could be a lot of room how to extending the memory telemetry, right? Defending new set of memory telemetry could be either in the redfish DMTF, or it can be a store either we store the data to the ISPT inference to the JEDEC. Could be some lifetime memory error statistic or detected memory component reporting from the memory error perspective. And we have the idea well, before is how we can extending the redfish, and we can discussing the proposal in the next meeting. We have the people can dive more in this topic. And second area, we can work in the work group as Drew mentioned, pretty well think the vendor agnostic architecture for memory error handling. And from our perspective, there could be a two type of analyzer, and that is not could be the gap, and we can fulfill. One side is a memory vendor specific analyzer. That analyzer will be memory architecture aware and DRAM fault mode analysis of DRAM fault underlying. And that will be in the bank or RAM granularity analysis. What are the underlying DRAM fault? They totally depend on the DRAM architecture. The second part of the analyzer could be either the SoC or CPU vendor specific analyzer. Those knowledge require the platform highly depend on the platform ECC, aware how the ECC knowledge given certain memory fault, how likely a fault could be a UE or CE if in the platform level. And that will be linked to the platform RAS capability and the configuration, and will be the cross the platform level analysis. And we can using that work group to modularize the inputs from the different vendor for the different module and define the API crossing the different the component. And Drew, if you can scroll a little bit, scroll down the
Oh yeah,
document.
sure.
Yeah, yeah, I
And
can
also,
do that, right?
I'll
Yeah,
see if I can make it a little bigger.
yeah.
Is this what
If that is
you
a
wanted to show this, right?
Yeah, want to show this a little bit bigger the point of view. Just anyway, we can getting a better picture to describe that. But the idea is if you look at the free scale memory error, from a temporal perspective, we see that there could be a transient error, intermittent error, and a permanent error, right? And most of the transient error that could be caused by the random, the concurring or partial, that could be the random failure. And in given we see that will be given the transient error, there will be a relatively lower risk to the fatal uncredible error, because in most of the transient error could be single bit, and currently the most effective way to cover the transient error is by the ECC, either host side ECC or DRAM side on that ECC. That design can cover most of transient error. Another side we're thinking is for the intermittent and the permanent. That will be a repeatable errors in the DRAM. And that error can be a multi-bit and can be a crossing different bank. That will be a broken bounded fault we design in the DDR, even in the DDR5. That will be a higher risk to the uncrowded error. And we're thinking from the fleet scale, or worker group, maybe our target should be focusing on how we can handle the intermittent and permanent errors. As this is the target error, we define the RFU policy and the RAS actions. And in this error, if we look at the intermittent or permanent fault, we saw that there could be a first thing we need to do is identify the DRAM fault component. If that will be a repeatable error, and what is the underlying cause of that fault, right? That could be some reason to cause the feed got flipped. And that cause first, we need to know in the DRAM component level. Can we get in some fruits, either the server line fault or server line drive or memory line, try to get in the underlying fault. But this kind of knowledge will be coming from the DRAM architecture information to help the analysis. We see that part of knowledge will come in as a memory vendor specific analyzer. There could be a vendor code to do the component level analysis. Given that output, we also need a second part of the analyzer that will be relied on. You see the SOC vendor specific analyzer. In this part, if we know the underlying memory fault, we need to identify what will be the affected memory region, either from the system point of view, either which cache line could be impacted, which row column, or even which page could be impacted. And also analysis, given certain fault, what will be the risk to the uncrowded error? Can we making some RAS action or RAS action recommendation based on the platform configuration and available RAS results, either the PPR, page level sparing, or row level sparing, or ADDC. In this type of knowledge, we see if we want to do a fine-tuned analysis, that do rely on the platform level knowledge. Either the ECC information coverage is different by the CPU vendor or generation, and what the runtime RAS configuration and available RAS resource on the platform, and some address translation related to the platform. We know how the certain failure can impact to the system. We see that part will be require the SOC vendor specific analyzer. And all those output could be two sides. One is the memory telemetry. We can help to the troubleshooting or placement policy. Or the second part is the RAS action. Either we trigger the in-field repairing the RAS action to isolate the 40 bits, or we're making some RAS action recommendation to giving the cloud infrastructure to taking the RAS actions. Yeah, this is a pretty high level view. I think that in work group, maybe we can define the goal. Given each of the input and output for the building block, how we can making that is define the input output for the analyzer and making that a standardized.
Thank you. This is I really like this drawing in particular. It sums what we're trying to figure out how to do. If it's okay, I have a few comments for you, and I think maybe we open it up for other comments. But I'm gonna scroll up. We'll just maybe walk through in order. I think I really like what the overall idea you're proposing here. One thing I would say is we need to think about the telemetry. Our current thought is most of it is CPER, and so it'll be interesting as we talk about these data sources. Some of this may not be an error log, and so we'll have to figure out, do we need like a place in Redfish to put other standard data like training data, or serial numbers or something, or what do we embed into the CPER error logs? I think it'll be good, and I don't know how standard we can make it between CPU vendors if they have different logging capabilities, but maybe we can make it standard enough to feed the analysis tools. I don't know. That's something I've been scratching my head on, is that the vendors log errors different ways, the CPU vendors. So we have to reconcile that somehow and make it work. And it could be that we have an abstraction that we kind of translate what the vendor logged into something that says, you had a bit flip at this location. Those were my initial comments for the first part. Any other comments from folks?
I think one thing I would thanks Shen and Drew. I think this is good analysis and initial scoping of what we need to do. I think it covers all the aspects initially. One thing I was thinking about is, as Shen was going through it, is maybe we can, as a next take, right, when we go deeper into each of these sub-bullets and maybe start putting some vectors to it in terms of what is the nature of it. Is it proprietary? Is it standard? What part is standard? And then maybe we can have some kind of agreement around the room from various providers of the data or vendors about what they are willing to do on that particular item in terms of which information can be made available in a standard format, or would it be that we define the format and the information is still somewhat specific to a vendor or a combination of vendors. So I think next step is to have it tabularize some of these items, and I think that's where all our work will go to figure out what we need, who is providing it, what is their comfort level, what can be standard, what needs to stay proprietary, where is that boundary? Because there's a lot of value add innovation that will take place at each vendor level, and that's where the trick is, right?
And I think that's the beauty of like drawing the boundaries where the vendors build the analyzers, is they can hopefully, I agree with you strongly that we want to figure out ways to encapsulate IP so that we don't we protect the IP, but we also take advantage of the vendor knowing their IP and the conclusions they can draw from it. So I really resonate with what you're saying, Yogesh. Any other comments from folks? The memory folks are quiet today. Are we on base, or was this looking? Are you uncomfortable? Are you comfortable?
Oh no, I think we're fine with the outline of this. Our interest is just trying to work together to figure out how to actually implement it, and if there's any limitations of the hardware to support the ideas here that are captured here.
Okay, sounds good.
Yeah, agreed. I think the outline overall looks good to me, Drew.
Okay, thank you, Evan.
And thanks for putting that together, Shen. I like that flowchart a lot.
So yeah, and I guess I think I personally welcome people. This is kind of the kickoff document. I mean, we're going to have some artifact later on that hopefully we generate that talks about how all the pieces fit together. But in the meantime, please feel free to jump in and put your stuff here. Okay. Any other comments before we move on to the stuff that I put in?
So we have, I think we have a good representation from system integrators, DRAM vendors, silicon vendors, and True, I think I feel like you're the only one who's representing CSPs. You need to bring more folks here.
Okay.
But yeah, I think that that's what I would visualize, to have feedback from all different stakeholders on each of the topics. What is their desire and how? And
Yeah.
yeah,
Well, and we can mention it in the Friday meeting and try to get, Neil or, some of the folks from Microsoft to join us. I'd love to see what they have to say and get their feedback. So, but Yogesh, I think we just need to recruit them on Friday.
okay, yeah.
It may be a little early for some of them. I know.
Yeah.
I got up at, since I have a long commute, I got up at around 4 or something. So anyway, but it's worth it. I'm excited about this. So I'm happy to get up at 4 if we get this done. Okay. So that then let's scroll up. So I was just kind of thinking about what goes in and what comes out, and I don't know. I'm you know trying to guess, and so if you all have better information, but I'm thinking, we have sources of data, and like from the CPU, we get their ECC information. So, the channel address of the error, which bits were flipped, ECC syndrome. And, one of the things I've seen is that sometimes the ECC syndrome for uncorrected errors can be interesting, especially if you have a series of corrected errors that led up to it, then you can see sometimes a relationship between them. And so that's kind of a weird thing. I know it's uncorrected in the EC. If the ECC was able to tell which bits were flipped, it would have just corrected it. But I think there is some interesting data there. And then, patrol scrubber errors and whether it was, patrol or demand scrubbed. Retry information. So, and maybe in the future that you get an uncorrected error, and we come up with a way to run a memory test on the failed memory line somehow. Who knows what we can do in the future, and the CPU vendors will innovate. So, if we have something like that where we get more information about the failure, that seems relevant. And then, when the errors occur so that we know the rate and the frequency. I was thinking the DRAM ECS, so for DDR5. And hopefully we can make it better. And maybe we could also propose improvements, because that data could use some improvement. It's kind of hard to get, and we don't get enough information from it. And then post-package repairs used and left. And then, I don't know much about the PMIC or RCD. I'm wondering if there's anything from them. If the PMIC can log a power
Yeah.
problem, that seems relevant.
Joe,
Is that? Yeah, go ahead.
yeah, that's a one concept for the PPR. We see if that could be the software PPR and hard PPR, right? And
Mm-hmm.
given the software PPR as the JEDEC defined, there will be only one PPR slot per band. I think either that could be either use the software PPR or you use once, or there is a use out, right? The more
Yeah.
question for the hard PPR, you may have more than one slot for the hard PPR for bank, but hard PPR will require you reboot the system and taking advantage. Right? If that will be a system reboot from cloud vendor perspective, you think that will be that's still useful, or what will be the use case you get a hard PPR? That means you do need a system reboot to taking that, right?
Oh, absolutely. And the hard PPR is very interesting, because from a cloud service provider, if I have a fleet of a million machines and I have an occasional memory error I want to fix, not having to send someone out to fix, we'll have a fair number of memory failures with a large fleet.
Mm-hmm.
So, avoiding human interaction and just doing a reboot's great, especially on our internal workloads, because at Google, we have highly fault tolerant software. So it's not a big deal to take a machine and just reboot it. But so that's a little different from a typical enterprise. So cloud customers, enterprise customers, they tend to be a more sensitive to reboots, and then our internal workloads maybe are a lot. They're pretty much fairly insensitive. But I think what I was imagining is with PPRs, well, they're going to distort our view of what's failing in the part if we don't know that they've happened. And so if we track that they've happened and we can tell the memory vendor, here's the series of PPRs we've done, the memory vendor can use that as they do their analysis um, to figure out the health of the part. Or, memory vendors, it may be possible in the future. I know there are registers in the DRAM, and it could be that we pull some registers in the DRAMs to get information about, whatever the DRAM's doing internally, health-wise. So, yeah, I don't know. I'm not sure how that would work. So I'm throwing things out, and some of my ideas are probably pretty bad. I think there's sounds like something banging. You all hear it?
Yeah.
Okay, caller two. I think it's you. And I'm going to mute caller two. So, oh, there you go, caller. Okay, thanks, caller two. And feel free to unmute if you want to talk. We're not trying to cut you off. It's just the noise was a little distracting. So then, I don't know. Does the PMIC can we log power failures?
Yeah, there's registers in the PMIC that you can read out. You can read at runtime, or you can read. There's some non-volatile registers as well about the health of the PMIC.
Okay. And I mean, and so that's what I'm trying to do is say, hey, is this interesting? And it seems like it might be because, if a DRAM fails and the power's bad, then the DRAM's probably fine. Okay. And then what about the RCD? Is there anything in the RCD that we can log? Does anyone know? Okay, I don't know. I've looked at a few RCD specs, but I wasn't looking for error logging. Um, so we'll just have to go look. And then I think temperature information is typically pretty interesting. And then I was imagining SPD, there's my experience with silicon vendors is they really like to know the serial number because they know what their manufacturing was doing for that serial number, so they can trace a lot of things back from that, or the date manufactured is also something interesting. And then maybe there's other information. And then I was also imagining training results, so the I size, the bit error rate of the memory link, maybe some other parameters. I'm not real sure. And then self-tests. We have memory vendor specific tests, generic tests, and maybe the location of errors during tests is interesting. And I'm particularly interested in the memory vendor specific tests and, like a feedback path, right? If we have a way to log how well those tests are doing, then we can help the memory vendors optimize those tests to make them as effective as possible. And we can learn which tests are worth running and which ones aren't. We can tune how long they run. We can, maybe it'll help us find better patterns for finding failed parts. And finding failed parts at boot is ideal, right? It's much better to find it at booting than it is at runtime. So I'd like to see if we can gather data that would help there. So any other comments on the data? Am I missing anything? And if I am, when you want to put it later, that's fine too. But is there anything obviously wrong with what I'm thinking here?
Drew, I like it. I have one question. Is HBM memory going to be included, or is that too big of a step?
I don't know. I was imagining starting with DDR5 because that's what our fleet uses the most of, but we have a fair bit of HBM as well. So I'll put that as a question. Maybe we start with DDR5 and jump to HBM. I don't know.
Yeah, I think we'll want to treat them a little bit differently, but I think it's a good idea to get it in here for both.
Okay, sounds good. Yeah, and I agree. It's a different thing. Yeah. Okay, sounds good. Any other feedback, comments? And please don't be shy. In our Friday meetings, we have folks like Mark Fletcher who are not shy and speak up. And the beauty of it is that it sounds like an argument, but we end up having a really good conversation and learning a lot. So, please feel free to push back or argue or, uh, tell me where I've got it wrong. I love it. I want to get it right.
Drew, when it comes to HBM memory, do you also want to treat the interconnect? Do you want to deal with problems of the interconnect itself?
Uh, Probably. Here's what I would say is, the memory vendors and SoC vendors are the best people to develop tools to figure out what's going on there. And so it seems like that would be relevant. And the problem I see is that if we screw up, we could blame the memory for a problem with the interface. And our goal is to attribute failures accurately so that we can improve our quality. So it seems relevant to me.
Okay.
Does anyone feel like that's a bad idea?
Yeah, that makes sense.
Cool. Okay, and then I just made up a flow of how I thought things might go, and let me make this fit. One more time. Okay. And I'm not deeply, this can change, but the boot time error data is gathered by firmware running on the CPU. ECS data is gathered by the memory controller. ECC data, is calculated by the CPU, and that would go from the CPU in the proposal we've been working on Fridays through the BMC to a collector that collects it in the cloud somewhere and has a time series data. And we can be flexible about how this works, but I'm imagining there's something that collects data, and then we're figuring out the analyzers. And what I'm hoping we can figure out is how does all of this work, the logging on the left, and then on the right, how do all the analyzers play together? And I honestly don't know. And you know what, this picture, okay, it's probably easier to look at this way. Um, but there's what I'm imagining is we also get clock power thermal data. We analyze it, and I don't know if these are sequential. Like, does this? Oh, this should say
Yep,
memory.
yeah, you have CPU vendor twice.
Yeah, nope, I meant memory. It was cut and paste error. So I don't know how this works. There's got to be something that gets the like which bits were flipped out of a CPU error log, and then that would go to the memory vendor. And so there's
Yeah.
some relationship here that I've drawn intentionally incorrectly, because I'm hoping we as a group can figure it out and fix it. And then there'll be a clock power thermal thing that maybe, I don't know if it's related or separate. And then, we can say, okay, based on all of the conclusions we got, there's some end action we think should take place. And the action could be, the actions I'm imagining are, a notification that we have an increased risk of crashing, or replace a part, or take some RAS action like a PPR or map out a bad page.
What comment, Joe, from the I was thinking that could be if we look at the memory vendor analyzer and the CPU vendor analyzer, I think that could be a some sequential. That would be a first getting the memory vendor analyzer for the memory fault, and then come to the CPU vendor analyzer to analysis at the platform level, coming to ECC. That will
Well,
be I thought will be the
yeah,
logical sequential
but
in the
it may be
flow.
that it may be that the CPU vendor has to decode which bits are flipped and send it to the memory vendor in a way they can understand it, and then the memory vendor talks about the scope of the failure in the part somehow back to the CPU vendor, and then the CPU vendor's analyzer goes, okay, based on the ECC capabilities in this
Right.
chip,
Yeah,
but
you're
it may
right.
be a
Yeah.
back and forth, right?
Yeah. We can give maybe draw some high level idea for the architecture, but not level detail. Yeah, I think that would be
Yeah.
some sequential there. And also
So
the comment is,
I intentionally drew it wrong. So I know it's
yeah,
wrong. I promise you. And
yeah,
that's what I'm hoping you can help us fix.
yeah. Okay. And also, I think that the architecture, if you look at the memory analyzer and the CPU analyzer, it's more the logical component. And architecturally, we think we can either fit to the BMC-centric architecture or inbound-centric architecture or cloud-centric architecture. I think that
Yeah.
either to be more flexible, the IP block can fit to the different architecture based on the solution choice. Right?
Yeah.
I agree. And yeah, from a Google perspective, I'm less interested in the BMC doing an analysis right now, and I'm more interested in cloud scale doing it in our cloud. But I know other people
Yeah.
may want to do it in the BMC. So, we'll have to talk about, this is just code. Where do we want to run the code?
Yeah.
Yeah, yeah, that's one of the thoughts I also had through, because from our experience in hardware fault management, I think there are differing views of from the system and from the error handling philosophy perspective. So trying to retrofit can be a little challenging. I think if we, at the get-go, if we think in terms of what is needed, and then we can define where all it can run or go, if we can get to that level of granularity. So keeping
Yeah.
other models in mind. So BMC centric, as Shan mentions, is one of the prevalent ones, and then I think we also have to understand what we're trying, how would it work in invent manner, right? Where would the analysis take place?
Right. You took the words out of my mouth. And I think even with the N-band, like I've talked to folks like Anil Agrawal at Meta that want to use N-band, but they still send the data off platform for analysis because the platform may not be healthy enough. So, I think we'll have to ask them how they think it would work. But my understanding was they still have, some analysis they do outside of the platform. And just from a fleet scale operations perspective, the problem is I could roll out a new analyzer and then start shutting my whole fleet down because there's a bug in the analyzer that says, oh, this machine's about to die, go down. And so typically what happens is there's some rate limiting in here where the actions get moderated by limiters that say, you know what, you've just taken 10% of my fleet out. I'm going to stop you now. This doesn't smell right. 90% of our DIMMs didn't just fail, or something. So we'll have to work that out. And I think it'd be good to get Microsoft and Meta here to also see how they do this kind of rate limiting. But it's not optional. It's like something you got to do. It's just how you do it may be different.
Another important one is, and we have Kevin and Hank here. So from the OEM perspective, if there are considerations that we have to take in from firmware first point of view. I'm not sure what I'm talking about, to be very honest, but we just want to.
Well, I mean, I think like because I worked with Jeff at HPE, right? I mean, you got to like fix your systems and manage your warranty costs, and it's important. So yeah, I think I'm confident that the system vendors will have input as well. The deal there is a little bit different because they're selling a warranty for a machine and analyzing a machine at a time. And so that's been my experience where when I think of machines, I'm thinking of all millions of them. And how do I manage, have some coherent thing that applies workloads to all of them? And so, but I think that if we put the flexibility in that we've been describing, where you can run at different places, then I sure hope, Jeff and Kevin, that we can, do something that's relevant to you all. That, maybe you run the code at a different place than we do at Google, and that's great. But I just can't help but think having a better analysis tool helps you. And please speak up, Kevin and Jeff. I know Jeff well enough that he will, but Kevin, yeah, I'd love to hear your thoughts.
Yeah, I mean, I absolutely agree with that. I think from some of the discussion that's been going on here, I guess one of the questions that I have is there's a part of this problem that is what information needs to be captured, and then there's a part of this problem that is what do we do with that information once it has been captured? And I think that
Yes.
I understood that the point of this was focused more on initially on the former than the latter, that we have to get it right of everybody gets all of the information they need to make whatever decisions they need to make. And so coming to a consensus about that. And then I already understand from some of what's already been discussed here that yes, there absolutely can be vendor proprietary at the CPU, at the memory vendor, or maybe even at the subcomponent vendor potentially, differences of how that information gets utilized to make a decision. But the starting point was so, which again, to your point, is like agnostic of where it gets done. It could be done in the BMC, it could be done in the OS or something, but defining what information needs to be captured, right? Is that?
Yeah. Yeah, and I think we really care about both the analysis and the data, but here's our proposal. This is the overall proposal that we're building on in this group that we've been working on in our Friday meetings. And there's a link to the document you can take a look at. I think our goal is to make it so that I can go to Intel and say, Intel, you have, 10,000 pages of registers that I don't understand. I don't know what to log. Give me some code that I can run somewhere that logs all the information I need to debug my machines. And they log it. And it'll be memory information, it'll be CPU interconnect or cache failure information, who knows what. And then I can go and say, give me an analyzer. So like Carlos here is working on analysis tools. And so we can then pass whatever data the CPU vendor and memory vendor set to log to analyzers that help us draw conclusions. And so I think what we're trying to do is empower the the silicon vendors to gather whatever they want, but to give us tools to make sense of whatever they gather. And of course, not when I say whatever, I don't mean whatever, because we can't gather personally identifiable information, or we can't snoop data from the machine that a customer might be using. But as far as chipset errors go, we want to know what's going on in the part. So does that make sense, Kevin? Is that we,
Oh yeah, yeah.
and I don't care how standard it is, even what's in the error log, and other than we need to standardize it enough that we can analyze, that the memory vendors can build analysis tools. So, but if like one CPU vendor builds some marvelous new thing that helps us figure out how things fail that we never had before, that's competition and it's good, and they should log it, and we'll take advantage of the superiority of their solution. Carlos, you look like you were going to say something.
No, I was going to say that I agree that at the end of the day, we should just document what is it that we need to focus on standardizing and agree on this is the information that needs to happen to support the DIM vendors to perform some of their analysis and recommendations. And then we can look at how to fit that vision into this picture you have here. Because at the end of the day, memory error logs are just one category of error logs you're getting
Yeah.
from the full system, right? So
Yeah.
yeah.
Okay. Well, great. So what's next? Where do we want to jump in? I think maybe we should write, maybe make start a document and start with by putting some of the scope from Shen into it. And Shen, I'd like to refine it a little bit to also just
Sure.
mention that it fits into the effort I just showed. Like this is we want to fit it into the broader effort, and we want CPR logs and I'm not opposed to additional telemetry, but I want to make it fit in with build on our existing proposals. But
Sure.
it looks good.
Yeah. Yeah.
So
Yeah.
was that the next step? I mean,
Yeah.
what do we do
And
next?
in the next meeting, we think that we can some proposal we can discuss if we making the one side is the source of the data, another side is what are the new telemetry we can expose. We try to discussing some proposal for the memory error telemetry, what we can expose to the redfish or
Yeah,
the
yeah.
other standard. Yeah,
Well, so
the
maybe
paper is
that's
still.
something.
Yeah.
Oh, I'm
Go
sorry. I didn't
ahead.
mean to cut you off. Well, I was just going to say, I like what you're thinking. I think that, I threw out what I knew we might be interested in, but I have no idea what folks think. Maybe that's another thing we could do is ask the memory vendors to think about what they want to collect and let us, and if it's a proprietary thing or you don't want, memory vendors are sensitive of knowing who's collecting what, we can have an intermediate collect all the information and not attribute it to anyone. But I have no idea what the sensitivities are there. But we want to gather data for your analysis tools. So can you help us refine this list, I guess, is the question.
Yeah, absolutely. There, we Micron definitely has a laundry list of things, and we're happy to put them out there for everyone. We want everyone to collect them. So,
Okay.
yeah.
And
So,
Drew,
so,
one thing.
oh, sorry, go ahead. I'm sorry, Carlos, please.
No worries. I was going to say that, Drew, one thing that would be beneficial to start this document and the overall scope is to define our, objective, and it's section with a, sweet and short problem statement from your side, and maybe we can bring in more of the CSP providers or of what are the challenges you're getting today that we're trying to solve with this. I think that will help us set our somewhat to say North Star, right? Our objectives, so that we're always aligned to, okay, this is the problem we need to solve, and base our efforts on that.
Yeah, I'm happy to propose a problem statement, and then, doc with, and this is probably the same doc, objectives, uh, and then the other thing that we talked about is, data we want to gather. Okay, so I will take the problem statement, and Shen, I can copy. Maybe if it's okay with you, I'll copy the objectives into the document. We'll start a new document. I'll copy them,
Sure.
and then ping, Shen, for you to take a pass. Does that sound like a good plan?
Next meeting, what to talk about the proposal for the telemetry, memory telemetry.
Yeah,
What
I mean, I
we
think
can
that's the
expose
data we
to
want
them.
to gather, right?
It's not the data we want to gather. It's the data is outside we want to expose for as a telemetry. Having the memory error telemetry can help the troubleshooting or replacement with the new telemetry we can want to output.
Okay. Okay. Well, that sounds like a pretty good plan. What do you all think?
Good to me.
Okay. So Tony, I'm sorry, that was muddled, Yogesh.
Oh, I'm sorry. No, I just agreeing with you. It looks good, and I think we have a solid path for the next steps.
Okay. And Tony said he would, Micron was willing to give give us information on what they want. I'll ping Samsung because I see, I'm not sure they're here today. And then Paul, do you mind from SK
Yeah,
Hynix?
we'll put together what we think we need to do to, identify analysis on our side.
Okay, that would be awesome. Yeah, we want to make sure we get what you need.
And Drew, is this document in the same location as everything else?
I think so, but I just pinged the link in the meeting, so if you go to the chat,
Yeah, so
the
that's a good point. One of the things that needs to happen is to decide where we're going to keep and share all the information, all these things that we create. I heard that some participants may have access issues on Google Drive. So what I'm going to do is to have a poll out there and see if people need alternate methods. If not, then we'll just use Google Drive. And another thing that we need to, I think, start is ask our IT coordinator Kevin to create a wiki page for this.
Do you mind, so Yogesh, do you mind taking that as an action item?
Yeah. So you can. So, yeah, that should help us, the structure. And so what another thing it does is calls that are recorded, he pushes them to OCP YouTube, and then he can place link to them on the wiki page, I think. So we generally don't take very good notes and share them around. Our document is our notes. So if someone wants to go in details of different things that were discussed, then those calls are go to place.
Okay. Well, I think that's pretty good. If we can do that next week, we'll be in great shape.
Yeah, one last one. I see Sridhar here. Sridhar, I'm sorry, didn't mean to put you on spot, but just wondering which company from and what is your motivation? Sorry.
I'm from Microsoft. I joined Microsoft 6 months back. I'm working on the NIC program. Yeah, I've been looking at a lot of telemetric aspects on NICs.
Oh, welcome. Okay, I'm glad to have another cloud service provider here. That's great.
Yeah, thank you.
So is it
someone from ByteDance will join, but he's not sure. I talked with Neil before the meeting, say whether he will join. I hope he can join next time.
ByteDance Neil? Yeah. This time should work for him. And Drew,
I will check with him.
Okay.
Thanks, Sean.
Yeah. Andrew, also, I think maybe we can ping ARM and MPR folks again, because one of their handicap was the time. But I think if they want to invite someone from their side, they should know this meeting time for this meeting, right?
Yeah.
NVIDIA
Yeah, I can ping Lydia Warrens at NVIDIA. She's probably the right person.
Mm-hmm. And do you want me to ping Samir, or I can do that? I can
yeah, if you can. I will. Okay, I'll ping.
Oh no! If you, why don't you just write one email and just copy everyone on that? You don't have to. This is all open, so just let them know that, hey, just forward the invite to them and say, guys, just want to let you know that, hey, and I can do it as well. Whoever. You know.
It's fine. I can do it. I'm happy to send that message. Okay, sounds good. Okay, well, I think I did too much talking this time, but next time, hopefully, we'll have more folks able to chip in. So go ahead, Shin. I'm sorry.
Yeah, just one question. Maybe I see there's a call for paper for the OCP for the October summit. Is that, you think, is that too early for this work group proposing something? Or you think that we can
It's not. I think we can
make it
start
a,
talking about. So global
Yeah,
summit is October, right? Yeah.
yeah. You think that
I
would be
kind of,
too early, or we can plan something? Yeah. I just a new to OCP that question. Yeah.
yeah, I would say it's probably we won't have. I would be amazed if we have our first submission ready, but I think we could give a progress report or advertise the work we're doing and explain our scope and what we've done so far.
Yeah, and have some call to action. Just promote our goals and activities here and ask people to join. Yeah, we should definitely maybe a quick 10-minute also.
Awesome. Okay. Well, I think we've got.
Drew, since we have 3 minutes left, I just want to let you know. Yesterday, I spent some time at least on the talk that we have lined up for the virtual. And
Oh,
from today's discussion and the new material in this white paper, I think I'm going to be more creative. I'll steal and borrow pictures from here. I know you are way behind your deadline, but this is working on that.
yeah, I've been. For folks that don't know, because I work on what to do when things go wrong. When the thing's going wrong, I get real busy. So there's just been some stuff going on. I've been busy lately.
Yeah, no,
But
I was also when I said that what I had in mind is for you to get approval for that talk. So, folks, on 17th there is a 15-minute talk on general hardware fault management, and it's more specifically we want to talk about this group. It's a virtual tech talk, which me and Drew have our names on it right now. But if anyone else wants to join the conversation, it's a 15-minute talk. And that's what we're talking about, creating content for that. We both got a little busy, and I think part of it is we got more focused on the hardware fault management also. So we're working on
yeah,
that. And Drew, you need some approval from your internal teams
I
before you can
do,
do
and
it.
I'm late. So I'm going to take a look at what you did, and I will work on it over the next couple of days, hopefully, and
Okay,
get
yeah.
that submitted. Thank you. Okay. Well, with that, I think we're done.
Yeah, it's a great meeting. Thank you all, and hope to build up the momentum and keep it up.
Yeah, and if you all are ever in the Bay Area and want to chat, I have two things I love talking about: airplanes and fault management. So, look me up. I'm happy to chat.
Not at the same time, hopefully.
Hey, so I commute to work in an airplane because I can't afford a house in the Bay Area. And as a pilot, I appreciate fault management more than most.
Nice.
All right. Talk to y'all later.
All right.
All right.
I know.
Okay.
Thanks, everyone.
Thanks.
Yeah.
Bye.